Okay, Algebra 8, we are moving on to section 2.6, adding and subtracting unlike denominators or with unlike denominators. So I've tried to include a visual here to help us understand what that means, and we've talked about it before. You can't add or subtract something unless they're cut into the same size pieces. So we'll just start with this first here, and these are just models already done for you. It says, to model 1/2 plus 1/3, use two rectangles of the same size and shape. So these are the same size. This one's cut into halves, and we shaded half of it vertically. And then we have the second rectangle, and we're going to cut it into thirds. The other line would be right here, and we're shading a third of it. So then it says separate the shaded portions into equal sizes. So for example, I did have it cut into halves and I cut it into thirds. Well, now I'm going to cut them both into 6, and then I can shade half of it. And then I can shade a third of it. And then when you add it together, we have to have 1, 2, 3, 4, 5 parts shaded. So 1, 2, 3, 4. 5 parts end up being shaded, so what do we get? We get 5 out of 6. So we're going to do 2 examples similarly to that. Okay, so the first example, it's 1/2 and 2/5. So 1/2, now it's going to bug me if it's not nice and try to do this evenly. Let's see, do I have an edge here I can use? It's a little bit. No, it's not. Anyways, half of it. And then we've got 2/5. So I've got to cut this one into fifths. Let's see. 1, 2, 3, 4, 5. So 1/2 and 2/5. Okay, so then the third step is to take this shape and we're going to cut it into equal parts. So down the middle, and then we'll go the fifths. 1, 2, 3, 4, 5. So, man, Mrs. Goldberg is not doing very good evenly. That's a little better. Okay. So again, we're gonna take this and we are gonna shade, and if you picture these, I have to shade a half. Okay, and then I like to just kind of picture this like this. 1, 2, 3, 4. We've got to shade 4 more. So 1, 2, 3, 4. So what do I end up with? Well, this is in tenths now. So this is 9/10. Okay. It's 1/2 plus 2/5. What that actually equals is 5/10. This would be 5 of them. And then this would be 4/10 equals 9/10. And this is just to give you a visual. Okay, the next one, we're going to cut this block into thirds. So, and I've got a third of it. And then we're going to cut this one into fifths. And we want 3/5 of it. Okay, and then this block, I'm going to cut it into thirds and into fifths. Okay, and it's even helpful to visualize these cut into those as well. Oh, goofy me. Okay, so now, really, I have a third to shade. But then I also have to shade 1, 2, 3, 4, 5, 6, 7, 8, 9 more chunks. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this was 1/3. This is 3/5. So this is 1/3 plus 3/5. But really, what this is 1, 2, 3, 4, 5 15ths plus 9 15ths equals, and then it's almost all the 15ths except for 1, so it's 14 15ths. Okay, but you can't add them together unless they're the same size parts. So we are going to do a little more work with this. So it says to add fractions with different denominators, first write the fractions with common denominators. To find the least common denominator of 5 and 6, write the multiples of each. Now you guys don't have to write these out necessarily, but this is one way to do it. So the multiples of 6, we did this in 7th grade, 6, 12, 18, 24, 30, 36, ... 4, 8, 12, 16, 20, 24, 28, ... Okay, so then you want to find the least common denominator of the two. Well, it's the least common multiple. So they both can go into 12. You could have a denominator of 24, but that's not the smallest one. Okay, so the next one, the least common denominator of 3 and 7. So let's list our 3s. 3, 6, 9, 12, 15, 18, 21. Let's do our 7s. 7, 14, 21, 28. You guys should be able to see that the smallest denominator is 21. Okay, so what they're saying is to add fractions with different denominators, you have to multiply, like we had to multiply the 1/2 by 3/3 and the 1/3 by 2/2 to have the common denominator of 6. So we're going to do some of these together. So, and they are obviously setting them up differently because they are, they wrote them like vertically, which is something that we don't tend to do, but that's okay. So they're telling us that 4 and 5 have a common denominator of 20. So we would multiply the 4 by a 5/5 and the 5 by a 4/4. So this is going to give us 5 20ths, and this is going to give us 12 20ths. So it's 5 plus 12, 17 20ths. Can it be reduced? No, that's your answer. The next one, I know that 4 can go into 16, so I do not need to change this number, but I'll just change the top one. 3 times 4 is 12, and then this one just stays the same. So 5 plus 12 is 17 16ths. That can be simplified to 1 and 1/16. Okay, so now we have a mixed number. A mixed number is when we have a whole number and a fraction. You don't have to touch the whole numbers when you're adding, okay? And so we're just going to take 3 and 8. They've already told you that they have a common denominator of 24. So for example, I know I'd have to multiply the 8 by a 3 to get to 24, so you have to do the same with the top. And then the 3 would have to be multiplied by an 8, so you have to do the same thing to the top. So they're kind of giving you one step. So now you add vertically. So what's 15 plus 8? So 15 plus 8 would give us 23 24ths. 5 plus 2 is 7. You can't reduce 23 24ths. Okay, so now we're going to just look at them. So this one, I know that 4 can go into 20, so I'd multiply this by a 5/5. This is going to give me 5 20ths plus 7 20ths. Once they have like denominators, 5 plus 7 gives us 12 20ths. I need to reduce that. They can both be divided by a 4. 4 goes into 12. I'm just going to show that here. 4 goes into 12 3 times. 4 goes into 25 times. Okay, now we've got a subtraction one. You can treat subtraction the same. What can both 9 and 5 go into? Well, if you kind of go through, the only thing that I can think of is 45. So I'd multiply this one by a 5 over 5, this one by a 9 over 9. This gives me 20 45ths minus 9 45ths. So now 20 minus 9 gives us 11. And that's all we can do. 15 and 4, what could they go into? Well, think of my multiples of 15. It goes 15, 30. 4 can't go into 15, can't go into 30. Then it goes to 45. 4 cannot go into 45, and then it goes to 60. So, then if you are having trouble, you can always check. So like 60 divided by 4 goes in there one time. And then it goes into 20, 15. Just so you guys, if you can't see that off the top of your head. So in order to get 4 to 60, you'd have to multiply it by a 15 over 15. In order to get the 15 to 60, you'd multiply it by a 4 over 4. This gives you 32 over 60 minus 15 over 60. So this would be 17 60ths. My handwriting got a little crazy there. You can always do this off to the side if you can't do it in your head. 5, you can't take away from the 2, so you borrow. 12 minus 5 is 7. That's how I did that one in my head. Okay, let's do one together from this sheet. Let's do number 12. 12 looks kind of tricky. Okay. So a couple different things going on here. The first thing that I notice is that I don't have like denominators. The second thing that I notice is that I have a negative and a positive. So let's take them to like denominators first. So 6 and 4, we know from just other practice, they both go into 12. So I would multiply my 6 by a 2 over 2 and my 4 by a 3 over 3. Do not touch your whole number. So 1 and 10 twelfths plus a negative 2 and 9 twelfths. Okay, so now what our problem is that we have a negative and a positive. And when I look at this, my negative is bigger. So when I subtract, I technically, and I'm going to write this off to the side, I have to take 2 and 9 twelfths, and I have to subtract 1 and 10 twelfths. Okay, but here's the trouble. I can't take 10 away from 9. Okay, so there's a couple things that we do. The easiest way is to think of this as like a subtraction problem. You can't take 9 away from 10, so you borrow. So I have to cross the 2, and it goes to a 1. Now, when you borrow a whole, and you've got a fraction over here, you are actually going to add, instead of a 1, it's 12 twelfths. 12 twelfths equal 1. So what is 9 plus 12? Well, it gives us 21 twelfths. So this number and this number is now what you're going to subtract. So 21 minus 10 gives you 11. And then 1 minus 1 is nothing. So this is your answer. Let me see if I see another one like that. This would be 9, 15, 10. Oh, and this one's also going to be negative, sorry. Just trying to see if I can predict any other ones that you would have to borrow from. Maybe this one. Well, that's adding. Well, let's do one more with a... We'll just do one more with a mixed number. Let's do number 9, okay? 8 and 12, what can they both go into? Well, think of your factors of 12. So it's 12, 24, 36. I know that 8 can go into 24, so I'm going to multiply that one by 3. This I'm just going to multiply by 2. So this turns into 2 and 21 24ths plus 3 and 10 24ths. This is a good example for us to do. So sometimes I really like to see it vertically, or if I just write it out like this. So you add the fractions. When I add the fractions, I get 21 plus 10, and I get 31 24ths. When I add the whole numbers, I get 5. But I can't leave this 31 24ths. So what does that change into? Well, it turns into 1, and then there are 7 24ths left over. And I need to add it to this 5. So this gives me 6 and 7 24ths. So sometimes you have to borrow, like in subtraction, and then sometimes you have to add it to the whole number.